Hey, what's up guys, Jeremy here. Today we'll talk about doors, or how you can create a sliding or rotating door inside RoboDK. Let's get started. For this example, you can open the folder 06D door. In this one you have two sets of examples, so we'll start with the Mazak CNC Lathe and Mazak CNC Lathe door. So let's zoom out a bit here, perfect. So here I have a simple Mazak lathe, and it's split in two different pieces. So I have the body of the machine, and I have the door here. So if I want to create a sliding door with this one here, the only thing I really need to do is create a frame that is where the x-axis is pointing in the direction of the open and close motion. So let's start by creating a frame. So I'm gonna go here, create a new frame. I don't know exactly where it is, but I'm gonna right click and then frame on so I can see it. It's right here in the middle of the machine. So I can simply press plus a few times. I'm gonna move it here towards this side of the station, and I will move it here. So it's perfect, I don't need to align it, it's just so that I'm pretty sure where it is. F2 here, I'm gonna call it frame base once again. So just like that, I'm gonna go and tool or utilities, and model mechanisms and robot. Once again, a sliding door in this case is just a linear axis, so let's call it door. We'll go for frame base, and then in terms of base, it will be the Mazak machine. And then here the moving part will be the door. So the door will go from 0 to, I'm not so sure how much really, but we'll go for a guess at 700 for now. And we'll just go for update. Once again, it created a copy of the 3D model, so I can hide the original ones. And I can simply try to here see if this moves. So it does indeed work, and as you can see here, 700 millimeters is pretty much the maximum motion I can get from this one here. Cool. So this is okay. I can now create a small program with this one. I'm gonna hide here tool frame, the ref frame, the tool, the robot flange. I don't need to see those. I'm gonna right click and reset this here. Perfect. Great. So starting from here, I can create my open and close program. So I'm going to create here a first position here. This will be my closed, or in fact, door closed. And I'm going to create a new one here. Oops, not here. I'm going to create a new one here when the door is open. So door opened here. Perfect. So I have closed, door opened. Great. Then I can create my two programs. Here, one will be open door, and here it will be close door. This one will be a simple move J to this one here, and this one will be simple move J to closed here. So now if I run if I run closed door like this, and if I run open door, it will open it like this. If I'm not satisfied with the speed, if I'm not satisfied with the speed at which things are moving, I can go to parameters and change the joint speed and linear speed, and change the acceleration or linear acceleration and joint acceleration. That would work. Okay, great. So that's how you create a basic sliding door. Now let's create a new station, Control N. So here we have our cell and the door. So here the door should be upright here and rotate around the axis here. So we need to first position the door properly and then move it around. So to position the door, let's start by creating the origin of the door here. Right now it's kind of right in the middle. That's not useful. That's not super useful. So we'll go tool, measure. We'll measure the center point here, copy that value, toggle that off, double click on the door, paste, and then invert pause, apply move. We need to rotate that 90 degrees like that, and 90 degrees like this, apply move. And now we just need to figure out the distance between this here and the center shaft here. So we'll reopen this one, clear selection, make sure the absolute is activated. And then I will come here, close. This one was simplified, so it's a bit harder to pick up measurements. I'm gonna click copy here, and then I will paste that up here. As you can see, I'm almost at the right spot. I just need to move it a bit upward like this, maybe another 5, so 455 essentially. Makes sense. Cool, that's great. Now I can close that here, and I can start creating my my frame, my rotation frame. So once again, the rotation frame will be here. So I already have it in my clipboard, but I'm gonna go measure just so that you guys see exactly what I'm doing. I'm gonna measure the center point here, copy, create a frame, and then here paste the value here. So the frame is right here. You can see here we have the x-axis and y-axis. So the z-axis is aligned with the center of rotation, which is what we were looking for. We're gonna call that here frame base. And then utilities, model mechanisms. We'll go for a rotative axis this time. So if you look at rotative axis, you need to have a frame which is in the middle of the rotation axis. I'm gonna call it door or cell door. I will go frame base. The base will be the cell. The joint will be the door. This one will rotate from 0 to 180, let's say. Click update. Created a copy. I can hide the copy and reset the position of this one. Reset. And here, if I now use my newly acquired slider here, I can rotate the door from one side to the other. So I can come here and I can rotate this one up like this. So either half a turn, so I can, so the user can put pieces here on this side while the robot is working on the other one. And as soon as it's ready, it can rotate. The operator removes the parts from this side while the robot is working on the other one, and then so on and so forth. So you can easily create a rotating door using this same method here. Okay, that's pretty much everything for today's video. I hope you liked it. In the next one, we'll talk about turntables and other positioners. So how you can create a rotative axis on which you can place objects so that you can rotate them and see in all around it. So that's super useful for inspection, welding, milling, and many other applications that requires you to have a lot of range of motion, which sometimes the robot can lack in certain configuration. So that being said, have a great day, guys.